Good morning, guys. Today we're going to continue on our notes. This one is titled Notes 1.03, Domain and Range, Part 1. There's two objectives today, but in this video, I'm only going to cover the first objective, and then in the next video, I'll cover the second objective, just so that we get familiar with one aspect, and then in the other video, we'll get familiar with the second objective. So the objective we're going to look at today is being able to identify whether a relation is a function or not a function. Okay, and so to start off, the question is, right, in most people's mind, what is a relation and what is a function? So in math, in algebra for this class, we're going to say a relation is a set of ordered pairs. Now, ordered pairs is another term that we might remember from Algebra 1. So just to kind of define it, let me go ahead and no, I'll leave it like that. Okay, so then a set of ordered pairs. So ordered pairs, you guys can remember from Algebra 1, is something that looks like this. It has a x and a y. Sometimes we call this a coordinate, right? X and y, a location. And sometimes we represent these coordinates. They can be represented with a list, a table, or a graph. Right? Sometimes we have a list of ordered pairs. So, for example, a list might look like something like this. And I'm just making up numbers, but we might have a list that looks like this, right? Let's see, 3, 5. This is an example of a list. Let me give you an example of a table. A table, you might have x and y, and you have 0, 1, 2, 4. So these are different ways that ordered pairs can appear. Right? Sometimes we might see them in a list format, a table, and of course a graph, right? Graph being with the x and the y-axis. Okay, but we should be familiar with these. We should be familiar with looking at relations that are in a list format or a table format or graph. Okay, the next thing I want to talk about is a function, right? What does it mean to be a function? A function is a relation. What's a relation? A set of ordered pairs, right? So a function is a set of ordered pairs in which the x value is paired with exactly one y value. So there's always kind of a pair going on, right? Kind of a partnership, that if I have a list of ordered pairs, or if I have a table of ordered pairs, or if I have a graph of ordered pairs, every x has a y. If every x value has a y value, then that set of ordered pairs is called a function. If every x value has a y value, every x value has a y value, that ordered pair with that relation is called a function. Okay, so what we're going to look at today is mainly about graphs. What is one method to figure out if a graph is a function? And so there's something called the vertical line test. It might be familiar from Algebra 1, but we're going to go over it again here. And if you do remember, great. If you don't, you could just follow along. So the rule for the vertical line test is the following. If a vertical line drawn through the graph touches the graph only once, then that graph is a function. Okay, let me say it again. If a vertical line is drawn through the graph and it touches the graph only once, then that graph is a function. Okay, so I gave two examples down here. Let's check it out. So my graph is the red one, right? It's this crazy curve here. So this is my graph. And the vertical line test says if I draw a vertical line at different parts, I can even add more lines to it, right? Let me say I add that line, this line, and we figure out, oh, look, it hits the graph here, it hits the graph here, here, and sorry, here and here. But every vertical line that I draw, how many times did I hit the graph, right? For example, in this line, how many times did I hit the red graph? One time. I drew another vertical line, I hit the graph one time. Another vertical line, I hit the graph one time, and another vertical line hits the graph one time. So the rule is, if I draw a vertical line and it touches the graph only once, it is a function. It is a function. So let me go ahead and erase this. Okay, let's look at the other example. What does it mean when we don't have a function, right? So let's say this red diagram is our graph. These red arrows make up our graph. And so there's a vertical line drawn. Wait, how many times did I hit the graph? How many times did I hit this red image? I hit it twice. Okay, what if I draw another brand new vertical line? How many times did I hit it? It's once, twice. Okay, so did this pass the vertical line test? If I drew the vertical line, did it hit only once? No, right? It hits twice in this case. So it hit more than once. So by that rule, this red graph is not a function. Okay, that red graph is not a function. Okay. The next thing I want to talk about is continuous functions. What does it mean for a function? You know, if we're talking about graphs, what does it mean for a graph function or a graph to be continuous? So it means that they are unbroken, single unbroken. You can draw the graph without lifting your pencil from the paper. Okay, so if you can do that, if you can draw something without lifting your pen, then that is continuous. Okay. For example, let's say I wanted to draw this graph in red. Can I do that without lifting my pencil, or in this case my arrow? Yeah, every time I lift it, it disappears, right? So, but I can draw it without lifting my pen. What about this graph? Wait, which one is the graph here? Is it the red dot, the red dash line, or the blue one? Well, let's see. What does it tell us about it? Let me zoom out a little bit. Okay, it says that the red dash line is an asymptote. We're going to learn a little bit more about that as we continue in the class, if you haven't heard about it before. And what an asymptote is it's the part of the graph that cannot be crossed or touched. Okay, so this red dashed line is a boundary that doesn't allow the blue graph to pass. So if the blue arrow, this blue graph here, if that's my function, is it continuous? Can I draw this without without lifting my pencil or my pen? Yeah, I can. So both of these are continuous, just that this graph in blue has a boundary to it. It still keeps going, and there's no breakups in the graph, so it's still continuous. Okay, let's look at the opposite. What are discontinuous functions? And there's actually 3 different types. Okay, so discontinuous functions are continuous functions for the most part, but they have areas that have holes, jumps, and asymptotes. Okay, they're continuous for the most part, but there's pieces in the graph that have, there's parts in the graph that have holes, jumps, and asymptotes. Now, let me go back a little bit. This graph has an asymptote, but the asymptote is not breaking up the graph into 2 pieces. It's keeping it whole and together. And then I'll show you down here what I mean. Okay. So let's look at the 3 types. We said holes, jumps, and asymptotes. So let's look at this graph. Can I draw it without lifting my pen or my pencil? Yeah, and some of you might say, yeah, of course, right? I can draw this straight line without lifting my pencil or my pen. But if you look at it closely, there's a hole right here. So this hole causes this line to be broken up into 2 pieces. So because that hole breaks up the line into 2 pieces, it's not continuous. Otherwise it would be 1 piece, right? But since it's 2 pieces, we call it discontinuous. It's broken, right? Let's look at the second category of discontinuous. Let's look at the jump example. Okay, so think of jump having, a gap in the graph. Meaning that, first of all, the graph, the function is made up of 2 pieces in this case, right? There's this piece, and then this piece that kind of curves, second piece that curves. But if you notice, there's a small gap here where the 2 pieces are not touching. And so this gap we call a jump. Okay, so this is an example of a discontinuous graph. What type of discontinuity does it have? It has a jump. It's discontinuous because there's a jump. This one's discontinuous because there's a hole. And the last category is asymptotes. And so here we have, this graph is discontinuous because there is an asymptote running through it and causing it to break off and split off. Okay, and actually there's 2 asymptotes on this one. There's a vertical one and a horizontal one. So again, these are boundaries that keep the graph from going past these boundaries. So if I'm following the blue curve, notice that it doesn't touch the red boundary. But it is discontinuous because these 2 pieces are separated by an asymptote. Okay, so let's go over it again. This graph in blue is discontinuous because there's a hole that's breaking the line up into 2 pieces. Here there's a jump that's breaking up the graph into 2 pieces. And here there's an asymptote dotted with this dashed boundary that breaks up the graph into 2 pieces. Sometimes there's special situations where there's more than one type of discontinuous feature to the graph. Okay, so let's look at the example on the left here. So this graph, first of all, would you say that it's continuous or discontinuous? And you would say, I'll just write it up here. I would say it's discontinuous for two reasons, right? There's let me write it in red. There's a hole right here, and there's a jump right here. So for these two reasons, this graph is discontinuous. The next graph on the right is also discontinuous. And let me use a different color since there's already red there. It's discontinuous because there's a hole here, and there's a boundary here that's causing the graph to break up into two pieces. So we call this an asymptote. Okay, so sometimes there's situations where the function or the graph that we have has two discontinuous parts. Okay. Right. So let's look at these examples. There's 4 examples that we're going to look at today, and then in the next video we'll go over the other 4 examples. So there's a total of 8. We're going to do 4 today. Okay, so let's look at the instructions. It says, state whether each relation is a function or not a function. Okay, so let's remember, what's the name of the test that we use to determine if something is a function or not? It's called the vertical line test. Let me just rewrite that. Vertical line test. There, it's better. All right, and if the graph is a function, then identify whether the graph is continuous or discontinuous. Okay, and so let's talk about the word continuous again. Continuous means, it's not broken into pieces. And discontinuous means that it is broken, right? And there's 3 ways that it can be broken. We talked about holes. There might be jumps in the graph. And asymptotes. Okay. So first off, is this a function or not? So let's do the vertical line test. Now the graph that we're looking at is a circle, right? And so what happens if I do draw a vertical line? Well, how many times does it hit the graph? I count 1, 2 times that it hits. Is that true for every vertical line that I draw? Let's see, 1, 2 times. Let me draw here. Yeah, it seems that every time I draw a vertical line, it's going to hit the graph 2 times. So we're going to say that this graph is it a function or not a function? It's not a function. Okay. Is it continuous or discontinuous? Can I draw this circle? Let me erase my scratch work here. Can I draw this circle without picking up my pencil? Yeah, if I start here and I draw the circle, I can draw it without picking up my pencil. So it is continuous. All right, let me go to the next example. And again, since this is a video, you can pause, you can rewind, you can go back to any part or section that you missed. Okay, so we have to state whether it's a function or not. So we have to do the vertical line test. So again, of course, if I draw a vertical line here, it's going to touch the graph, because remember from geometry, if you have arrows, they go towards infinity, so they don't stop. So eventually, this line and this graph will meet, and how many times will they touch? One time, right? So because of that, the arrow, we can assume that even though, even if I draw a vertical line over here, it's going to cross the graph eventually. But let's deal with what we can see. So let me draw a vertical line, maybe horrible vertical line. Okay, let me draw one there. All right, so how many times did it hit the graph? Just one time, right? What if I draw the vertical line here? One time again. So far, so good. It seems to be a function. Is there any part that is kind of a mystery, right? Is there a tricky part? Right? What about this hole? Well, what happens if I draw a vertical line right where the hole is? Well, this vertical line doesn't touch the graph here, but it does touch that point right there. So when does the vertical line and the graph touch? Right here. I'll color it in black. So far, the graph has touched the vertical line here, here, and here. Okay. So far, it's a function. It's a function. Okay, because again, a function means that anywhere I draw a vertical line, it should hit the graph once. Well, I drew a vertical line here and it hit once. I drew a vertical line here and it hit once. I drew a vertical line where the hole is, and how many times did it hit the graph? One time. Because remember, there's a blue dot there, right? So it does hit the graph. So that one was kind of like a trick question, right? Because it had a hole, but the vertical line still hit the blue part of the graph. Okay. So let me go ahead and erase my vertical lines, because we already finished the vertical line test, right? The second question is it continuous or discontinuous? And some students say, oh, I can draw it without lifting my pen or my pencil. That's true. But what do we call this? It's a piece of the graph that breaks it up into two sections. So it's continuous, but then there's a hole that comes up, and that hole causes the graph to be discontinuous. Now you might ask, what about this dot? Doesn't that make it continuous? Well, this dot helps the graph be a function, but it doesn't help the discontinuousness of it. Because in order for it to fix the discontinuousness, it needs to be covering that hole. So since that hole is there, as I'm drawing the graph, I have to lift my pencil to draw this point. I have to lift my pencil to continue the graph. So because I have to lift my pencil, that's the way that I tell if something is discontinuous. Okay. Let's look at 2 more examples. Okay. So first question is it a function? So to answer that, we have to do the vertical line test. So I know some of you might think, oh, what about if I draw a line there? Does it hit the graph? No, it doesn't. But remember, the rule says if it hits once or more. So it's okay if it doesn't hit the graph. What we're interested in is, does it hit the graph more than once? Okay, so I draw a vertical line here. I hit the graph. I can draw a vertical line here, 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 here. And since there's an arrow here, it keeps going. I can keep drawing vertical lines. And how many times do I hit the graph? Right? Every time I draw a vertical line, it hits the graph once. Is there any place that it would hit the graph more than once, like 2 times? No, right? So then it's safe to say that this is a function. So let me go ahead and erase this again. The next thing we have to decide is if it's continuous or discontinuous. Okay? So since this is the entire function or graph, let's check from start to finish. Do I have to lift my pencil? No, right? I can draw it without lifting my pencil. There's no holes, there's no jumps, and there's no asymptotes. So it's safe to say that this graph is continuous. Okay. Let's look at example 4. Our last example for this video. All right, first question. Is it a function? Well, we have to do the vertical line test. So that means drawing vertical lines and checking to see how many times did I hit the graph. Hit the graph 1 time. Okay. Hit the graph 1 time. Hit the graph 1 time. Okay, but the interesting part is this gap here. So I don't like my vertical lines today. Okay. If I draw a vertical line through here, how many times do I hit the graph? Well, it looks like it hits 2 times. 2 times. So did it pass the vertical line test? No, right? So in this case, this is not a function. This is not a function, okay? So let me go ahead and erase this. And let's look at the next thing we have to answer. Is this graph continuous or discontinuous? Well, it starts over here at this arrow, and as I'm drawing, I haven't lifted my pen or my pencil, but in order to draw it, do I have to lift my pencil? Yes, right, I lift it, and then I can continue from up here. So there's this gap here. We call this a jump. And so it is discontinuous because there's a jump in the graph. Okay, so that concludes our lesson for today. Join me next time as we discuss the second part where we talk about domain and range. But thank you for joining me today, and I'll see you at our usual Zoom time. Have a great day.